movie festival. Now, what does this problem states? Like, you'll be giving n movies, and you'll be giving the starting and ending time of the each movie, and now you need to determine what is the maximum number of movies you can watch entirely, right? So let us understand through a sample case. Like, see here if the movies are given, like, let us assume some ranges. If the ranges are not intersecting, can I say I can directly pick all these three movies, and I can watch them completely. So the actual problem occurs when they are intersecting, right? Suppose, let us say, assume the range 1 is like this, and assume a range 2 is present like this, and assume a range 3 is present over like this. That means here, let us say, here the first range, I can give you the first range as 1 to 3, and second range as 2 to 5, or let us say 2 to 6, and the third range is 3. It is, let us assume, it is like 5 to 8, right? So this is so this is our first range and second range and third range. So if you assume like this, then see here we need to pick the first range, which is 1, 3, and then you need to pick the third range, which is 5, 8, right? So here we need to pick these two ranges in order to get the maximum number of count, right? So that no two ranges are been colliding, right? So now let us assume another case. See here, if the ranges are present, like, let us say the first range is somewhat like this, and the second range is somewhat like this, and the third range is somewhat like this, right? You can take any of the coordinates, but if they are intersecting like this, now can I say I need to pick this range 2, and I need to pick the range 3, right? Because why? Because if you pick the range 1, then I cannot pick the range 2, and I cannot pick the range 3, since there is an intersection between these two, right? So in order to get the maximum number of ranges count, what we'll try to pick the second range and the third range. So if you carefully observe from this observation, you'll get one observation that is main. Like, what we are actually trying to do, see here, whatever the range is ending at first, that we are considering. See here, the first range is ending early, so we'll pick this range 1. Next, we'll check whatever the range is ending at the second time. See here, the range 2 is ending at the second early position, right? But since it is intersecting with 1, we won't be considering that position, right? We won't be considering that range. Now we'll go to third range, and we'll check whether it is intersecting with the 1 or not. So since it is not colliding, so we'll just take this third range also. So here, if you can observe in this case, see here the range 2 is ending first. So we'll try to pick 2. First, and then what is the range that is ending next? That is 1, right? That is 1. So we'll try to check 1. So since it is intersecting with the previous range 2, we won't be considering here the range 1. Then we'll again go and check for range 3, and we'll check whether it is intersecting with the previous range 2 or not. Since it is not intersecting, we'll directly take the range 3. That means you can get one observation. That means we need to just take whatever the ranges that are ending first. We need to take that ranges, right? We need to take that ranges, and we need to check it with the previous picked ranges, whether they are colliding or not. So just if I need to conclude, you see here, there will be some starting and ending range, right? Sort this pairs according to the ending range. Like, whatever the ranges that are ending first, you need to pick them first, and then you just need to check with the previous picked pair. Like, whatever the range that you have picked last, just check with that. Whether it is intersecting with the current pair or not, right? So that's how we will exactly do. See here, if I need to give you one sample case, like, it could be, see here, I'll be giving you just a small sample case, which is a 1, 7 and 2, 4 and 5, 8. If I have given you these three ranges, what I'll be trying to do, I'll be trying to sort these three pairs on the ending position. That means 2, 4 will be first, and then 1, 7 will be second, and then 5, 8 will be third, right? So see here, what I'll try to do is, first of all, I'll just go and pick this first pair, since there is no previous range. So now what I'll try to do, I have picked, see, I'll say some variable, and since I'm picking this first range, I'll update this ending time, which is a 4, right? Now again go and check for this 1, 7. So since see here our starting position is less than our picked range, can I say these both are intersecting? So what I'll try to do, I won't consider this pair, and now I'll move to the next position, and I'll again check the starting position with my last previous picked position. So since my starting position is greater than my previous picked position, that means it is indicating me like these are not intersecting at any time, right? These are not intersecting at any range. So even so I'll pick this also, and I just update my picked range as 8, right? So this is how you'll do, and you just increment these counts in another variable, and you can simply return that. So let's just quickly get into the coding part. So initially he'll be giving us n pairs, right? N pairs of integers. Let us say I'll be taking, let us say those, yeah, I'll be taking in my RR. Just take those ranges, like he'll be giving you a start range and end range, right? He'll be giving you a start range and end range. So you'll keep that in your array. Now you need to sort these positions based on the second value, right? So for sorting that based on the second value, I'll write a custom comparator function which will sort according to my given position, right? See here, initially, like if you just write only up until here, like the sorting will be happening by considering the start range, by taking priority as start range. But we don't want like that, right? We want to sort it according to the ending position, right? So that's why we are writing a comparator function over here, where will give the functionality, like where we can give our required functionality. So based on here, like whatever it returns you true or false, based on that here the sorting will happen. See here whatever the second value, like whatever the ending time is lesser than, is a lesser value, we need to sort according to that. So we'll just return true. Else if our x dot second is greater than y dot second, that means if our one ending time is greater than another ending time, like if this ending time is lesser, then if you return false, then that means this y will be coming first and this x will place second. So that's how it exactly happens. And you know, if both ending times are equal, just you need to return whatever the first value is lesser than that, you simply need to return that. Yeah. So once if this happens, now what you need to do, see here, initially my picked range will be -1. Now what I'll be doing, I'll be iterating through my array, and I'll just see here, if my pick is less than my starting range, right? Yeah. If my pick is less than my starting range, if my pick is less than or equal to, since here I'll be taking one count where I can, that is the count of maximum number of movies that I can watch. So if that is less than that, I'll just increment the count, and you know, I'll update my pick as the ending range. So after this, you can get the maximum count that you need. Yeah, if you run this, yeah, it should be 2, right? It should be 2. Now here, if I'm sorting this, yeah, like where can it go wrong? Where can it go wrong? First of all, we'll make sure one thing, like we'll just print these things, what is coming first and what is coming next. Here, okay, that means here I think there is, I have taken the input wrong. So what I'll try to do, I'll just push like this. Okay, sorry, I have just forgot to take the value n, right? Yeah, now it does run fine, it does run fine. So yeah, so this is what the solution